Hello. Today I'm going to be explaining a little bit about vacuum decay. So, this concept of vacuum decay comes from quantum mechanics and it still isn't a confirmed concept. Scientists still don't know if it is real or it isn't, it's just a prediction. So, to understand that, we'll first need to know about three things. First, quarks, leptons, and bosons. So these are the three fundamental things that make up everything in the universe. So quarks and leptons make up atoms, and bosons are basically made up of fields, energy fields, and they act as messengers or the forces that keep the quarks and leptons together. So quarks and leptons form atoms which form everything else, and bosons help quarks and leptons to stay in place. So it's these three things that make up everything in the universe. So I'm just simplifying everything so that it's not too complicated to understand. So then comes, see, quarks plus leptons plus bosons makes up matter, which makes up everything in the universe. So what exactly is nothing? So, to understand everything about vacuum decay, we need to understand what is the state of nothingness. So, nothing means vacuum, right? Means a state where there is nothing, no matter, and not a single particle of matter existing in that place. That's what we call vacuum. But this entire universe is like a chessboard. This entire universe is like a chessboard, and this whole chessboard is what we call the Higgs field. The Higgs field. So on this chessboard, there are these pieces that make about matter, just as we previously discussed: quarks, leptons, bosons. So these things make up the entire universe, and where they are acting is the Higgs field. Now, I'll just explain it in a bit more detail. So this Higgs field is the king of everything because Higgs field is nothing, but that nothing gives rise to everything. It's a bit complicated to understand. So just consider this to be the Higgs field. This is that chessboard, and it is just an energy field with no energy. It is fully stable and it is at its lowest potential energy. So because of that, it's like a calm ocean. In that calm ocean of the Higgs field, some little disturbances. The Higgs field is basically a wave, an energy wave that surrounds the entire universe. So, a small disturbance in this energy field gives rise to particles. So, a certain type of disturbance gives rise to a certain type of particle. Another type of disturbance gives rise to another part of particle. So, like that, there are three types of disturbances currently discovered, which are as follows: a certain type creates a quark, a certain type creates a lepton, and a certain type creates a boson. So it's the Higgs field that is nothing, which gives rise to quarks, leptons, and bosons, which give rise to everything. So I think the concept of the Higgs field is quite clear right now. Now we'll discuss what ground state is. So every object in the universe is governed by a rule that it always tries to reach its lowest possible potential energy. So for example, here this stone or diamond or whatever it is at this high point where it has a very high potential energy. This potential energy is very high, So it will try to come to such a state where its potential energy will be least or zero. Here the potential energy is very low or equal to zero, and this is called the ground state. Here in this ground state, the potential energy of the object is the least or zero. So like that, the Higgs field also is an energy wave, so it will also have some energy. So the Higgs field also has its own potential energy. So right now the Higgs field should be at its ground state because the world we are living in is stable. There's no random burst of quarks and leptons and bosons here and there. So we can consider our world to be stable. And that means for our world to be stable, the chessboard on which our world is playing should also be stable. So the Higgs field, which gives rise to our world, is also stable. So let us consider this. What is vacuum? Vacuum is a state of nothing. But here, nothing means no energy. Vacuum in this particular concept means no energy. It is a state with absolutely no energy level. So consider this red ball to be the Higgs field. Consider this red ball to be the Higgs field. This is just a diagrammatical representation of the potential energy model of Higgs field. So consider this red ball to be the Higgs field, and now we can see that if the Higgs field was here, its potential energy would have been really high. But as it is here, its potential energy is zero. But there is a possibility that this might be a state of metastability. Metastability is a concept, or it is a term which means that a particular particle is stable with respect to that particular system, but it is not in its lowest energy level. For example, we are on the earth and living on the ground, we have some potential energy which is not truly zero. To attain true zero potential energy, we will have to go to the core of the earth. There we will have zero potential energy. But as far as our system is concerned, we consider our state on the earth, on the soil where we live right now, to be a zero state because we are considering that particular system. So the current model of quantum mechanics and particle physics, scientists have predicted that it might be possible that the Higgs field might be in a state of metastability. That means it might not be entirely stable, just acting as if it is stable. So currently, it is in a if we consider it is in a state of metastability, the real condition might be something like this. The current Higgs field is here. It has some potential energy of this, but this is a false vacuum. This is a false state of no energy because the Higgs field had some energy here, even a little, but it had some energy. Now consider this point over here. If the Higgs field was here, its potential energy would have been absolute zero, which means it would have been in true vacuum. So consider a situation where this phenomenon of quantum tunneling happens. Quantum tunneling is a phenomenon where the there is you can consider it like a small spark which causes a particle in metastable condition to break free from that particular system and go to its true vacuum state. This phenomenon is called quantum tunneling, quantum tunneling. So now, if quantum tunneling happens and our current Higgs field warps to this system of true vacuum, then the energy levels would highly change. So, if at a certain point in space and time, just a sec. So, suppose this is this Higgs field, and suppose that tiny spark of quantum tunneling happens at this spot. This particular spot in the Higgs field would reach true vacuum, a state of true vacuum. From there, the energy levels would drop highly, and the surrounding area would also attain true vacuum. Then it will also trigger some more energy changes, and the surrounding area will also become true vacuum. Doing so, this sphere of true vacuum will start growing and engulf everything that comes into its past, literally deleting the entire universe. Mark the word delete, because it will just be like that. Everything that this field touches would turn to nothing, because it will be a state of true vacuum. But there is something even worse than this, because it will not only wipe out all life, it will change physics as we know it. Because, just as we previously discussed, quarks, leptons, and bosons are just disturbances on the Higgs field. If this entire Higgs field changes its energy level from this particular model to something entirely different, then the disturbances in this new model would create something else entirely, which will be different from the fundamental particles that we know right now, which are quarks, leptons, and bosons. If new fundamental particles are created, chemistry will be destroyed entirely. The chemistry as we know right now, the reactions between atoms, which ultimately gives rise to life as we know it, will entirely be destroyed, which means physics as we know it right now would not exist. So, which means the world would have no hope of attaining life again as we know it right now. But this concept is not entirely believable or not entirely confirmed by scientists, and there is a high chance that this might be not possible. But yet, it's a concept in quantum mechanics, and hence scientists have studied it. So, I hope you understood everything, and thank you.